Alright, CNT125, Chapter 12, Layer 1 WAN technologies. We're looking at T carriers now. A lot of information on this because we've been using T carriers for a long time. T carrier technology, there's T1s, there's fractional Ts, and there's T3s. And it's a dedicated circuit for only one customer. That's been the big appeal for many years on this technology. It's a dedicated link to our site and nobody else. In the 50s, AT&T developed T-carrier technology to digitize voice signals and enable longer distances. In addition, they did this as a way to, if you think of a neighborhood, all the phone lines in a neighborhood, I could take all the phone lines in a neighborhood, multiplex them together on a T-carrier, and send that back to the CO as a trunk line. That was another idea behind this. In the 70s, many businesses installed T1s to obtain more voice throughput per line. You could handle through one T1 line 24 simultaneous phone calls. So it basically was a trunk line for something like your PBX. 1990s, increased data communication demands. T1s became popular to connect WAN sites via leased lines. Yes, T1s got used because they were there and I could have a dedicated link from A to B. Medium for T carrier is a copper wire, could also be a fiber optic cable. Fiber optic being most common, but their copper wire was used for quite a while too. Alright, so let's start taking a look. T1, commonly leased by businesses, connect branch offices. Yep, connect to, Harrisburg site to Pittsburgh site kind of deal. The cost is going to vary from region to region, and it really is based on distance from a CO or a provider, if you will. The more rural you are, the higher it's going to be. The higher the cost is going to be per month. So they can range $200 to $1,200 a month. Yeah, 500 ballpark to 1,000 is pretty common. Longer distance, the higher the T1's monthly charge. Yep, absolutely. T carrier standards are the TE-CXR standards. They're going to use time division multiplexing. The idea there is you take a single cable and you break it into multiple channels. So that cable you're breaking into multiple channels, 24 if you will. And that single T1 cable can handle 24 simultaneous calls. Now, the time division multiplexing, think of that almost as like you're sitting at a train crossing and you're watching the cars go by. Each railroad car would be a chunk of data for that channel. So the first car go by, that's a chunk of voice data for channel 1, next one channel 2, channel 3, channel 4, channel 5, the whole way up to get to 24, and then it repeats over to the first channel. Now obviously those cars would be moving extremely quickly to do that, but that's how 24 simultaneous calls can be handled across that T1 line. Those are little time slots. Each of those little box cars is a time slot for each individual channel. So your T1 line can handle 24 simultaneous calls, each one capable of 64K of throughput, a phone line. So 24 channels times 64K gives you 1.54 meg of bandwidth. And each of these channels can carry data, voice, or video signals. So it gave companies a lot of flexibility on how it wants to handle these channels for usage. Here is your analog phone line DS0, 64K. Your T1 line, as you take a look here, is 24 channels, giving you a 1.54 meg of bandwidth. Your T3, this often got used if you had multiple T1 lines that you were trying to deal with. I might use a T3 to basically combine a whole bunch of T1s. Your T3 is providing 28 times more throughput than a T1. So essentially like 28 T1s, if you will. T3 is much more expensive than T1s because of the bandwidth. There's a lot more modern options that work better for bandwidth than the cost of T3s. Could be anywhere in the neighborhood of $10,000 a month for T3 line. So it gives you the cost of some companies have used those previously, finding other options down the road. Here's your T3. It's basically equivalent of 28 T1 lines, giving you 672 channels or roughly 45 meg of bandwidth. Fractional T's, companies could use a fractional T, a piece of a T, if they just needed a couple 64K channels, if you will. In this case, if somebody was using a fractional T, it was kind of like a business that might be expecting to grow down the road and might grow into the full T1, but I just need part of it for now. So fractional T's could get used. While we're on the T1 lines, we run into things like ISDN PRI and SIP trunk. So ISDN PRI and T1 are like buddies, if you will, and we'll talk about the SIP trunk as well. So let's take a look here. Your ISDN PRI is essentially a T1 with your channels slightly reorganized. Okay, so if I take a look at right down here, I'm going to jump down here real quick. ISDN PRI is essentially a T1, 23 channels, 23 B channels and 1 D channel, giving you essentially the same bandwidth, if you will. That's why they're kind of buddies. Okay, with a T1, T1 is actually T1 CAS, channel associated signaling, or Rob bit signaling. Part of each traffic channel is used for signaling. So instead of using another whole channel, 23 channels of data, or 23 channels of voice and 1 of data, the 24th one being for data, they actually rob a few bits out of each channel for signaling for all 24. I call it Rob bit signaling. ISDN PRI, 1 channel is dedicated to signaling. That's the difference. Okay, so T1, that signaling is broken up into the 24 channels. ISDN PRI, 1 whole channel is dedicated to signaling. The other 23 are used for your voice and data transmission. E1 PRI dedicates 2 D channels to signaling, 30 B channels for voice transmission. But as I look across all of these, they all support both data voice traffic. All those support data voice traffic, if you will. T1 PRI and E1 PRI, advantage of voice traffic is the allocation of channels for different purposes. Because I can use them for different purposes, I might be able to handle different loads or different needs in a facility. Your disadvantage with T1 PRI, the number of B channels defines how many calls can be supported at any given time. Because I have 23 B channels, I'm already limited just a little bit because I don't have that 24th channel. So I am limited on that. If an organization has more than 30 employees, you might need multiple T1s to keep up with the bandwidth needs of the phone calls in the company. Meanwhile, you run into kind of a more modern thing as a SIP trunk. If you think back to our voice over IP lab we talked about SIP. We even Wireshark SIP, Session Initiation Protocol. Your Session Initiation Protocol is used for your voice over IP calls. That's the main thing. So SIP trunking employs IP phone, voice over IP, to create virtual connections over an existing data service. So something like a Metro Ethernet, dedicated lease lines such as T1, SIP trunk can be used. Only limitation is the number of simultaneous calls or the bandwidth necessary, but all can run over a single data line. I don't necessarily need additional equipment, and SIP configurations will be easier to deal with and cheaper to deal with than your T1 PRI. So a lot of companies might use, I'm not sure if they have it here, here we go, yeah, might actually use a SIP trunk for their voice connection. Going back to our T carrier, your T carrier connection does require some equipment here, CSU, DSU, smart jack kind of thing for connection. Remember your smart jack from way back in the beginning of the chapter. This is usually located at the network interface unit. It's a type of network interface unit. Functions as a monitoring point. It's between the carrier and the customer. Can actually report back on the health of that link. The techs can actually check the status of the line at the smart jack, and there's usually LEDs indicating whether it's working or not. Smart jack is not capable of interpreting data, just relies on CSU, DSU for that purpose. Here's a sample of our smart jack, and I think I even have some more smart jack examples here for you too. CSU DSU, hopefully you remember this from earlier. The CSU DSU consists of a CSU and a DSU and serves as your data terminal equipment endpoint device for leased line. This could actually be a standalone device or an interface card. Your CSU is the termination for the digital signal, ensures the connection integrity through error correction and line monitoring. Meanwhile, the DSU is going to convert the T-carrier frames into frames of LAN for the LAN and vice versa. It's going to connect the T-carrier line with your terminating equipment, and this often includes a multiplexer with it as well. Here is a standalone TSU DSU, just giving you an idea that could actually be a standalone piece of gear. Here is an older T1 CSU DSU. Actually, almost looks like a monitor. Modem. That's kind of what it is. It's like a WAN modem. Here's another TSU at T1 CSU DSU, and I think I used this picture with you before. T1 line coming in, CSU DSU, WAN modem, if you will. Serial connection into my router. My router then can handle all the LAN signaling. Here is a module, a T1 module, an HWIC that would be slid into a router. This shows it kind of from the front. This also shows the top so you can see it slid into the router like so. Now I can plug my T1 right into that, and that's doing all those functions we just mentioned. There might be a multiplexer combined in with this because, again, your T1 line is a 24 channels multiplex together. So your CSU, DSU kind of thing might actually have a multiplexer built into it for that purpose. If not, it might actually be a separate piece of equipment. Typical T1 connected data network. DT is the router. Translates between different layer 3 protocols that might be used. CSU DSU is expansion card installed in the router like we showed you. Integrated with that, it's a little bit faster processing. I can handle that data a little bit quicker. And if you actually think back to the IP phone lab we did, we ran our IP phone traffic across this T1 line using these T1 CSU DSUs. So thinking back to that voice over IP lab, you recognize that those actually did work to move data across those links. Side note, the chapter did not actually, here we go, here's your smart jack right there, and then there's the router with the CSU DSU built in. I kind of jumped by that without mentioning that. Side note, when you deal with T1 cabling, here's your typical pinout that you would deal with for your T1 cabling. If you're connecting to T1 devices like we did in our lab, this is actually the pinout for a T1 crossover. You'll notice the oranges and blues are flip-flopped. That's an oddity. That's why I said when we were doing that lab, we used the special purple cables in lab because those are wired with the T1 crossover link. Alrighty, we'll come back in the next podcast and deal with Sonnet.